Well, good morning and welcome to Down to Earth, the webinar that looks at emerging satellite applications and how they're being used to improve people's lives on Earth. I'm Graham Turnock, Secretary General of Eurisy, an association of space agencies focused on trying to achieve just that translation to a satellite application-rich world in Europe. So we're very glad to have you here today to hear from two amazing speakers in the field of disaster risk management, an area where satellite applications really are making a big impact at the moment. And with me today, I have Charlotte Wirion, who is the co-founder and Chief Technology Officer of Wio, a European climate tech company based in Luxembourg. And then I'm also delighted to have with me Laura Moreno, who's the co-founder and Chief Executive Officer of EarthPulse, again, a satellite intelligence company based in Spain. And we were very fortunate to have both of these two wonderful people involved in seminars that Eurisy organized with USPA to promote the European space program and what that can do to help satellite applications in the field of disaster risk management. So the format of our webinar, as with previous webinars, will be to have a short sort of 10 to 15 minute interview with each of our guests. And then there's an opportunity for you, the viewers, to put your questions to them. We'll hope to then have a sort of 10 to 15 minute Q&A session where they answer your questions. And then we'll wrap up in hopefully around 45 minutes in total. If we don't get to everybody's questions, then we'll find a way of replying to you after the webinar. So that's all by way of my introduction. But of course, you've really come here today to hear our speakers. So I'd like to, first of all, invite Charlotte to enter the interview room. So Charlotte, you're the co-founder, as I mentioned, and Chief Technology Officer of WEO. Your background is in environmental engineering and remote sensing. And you've been very much focused on using AI and satellite data for climate resilience. And in this instance, we're going to talk a bit about disaster risk management. You've got a particular focus on really using satellite data to take action and also applying it in areas where there might be sort of, at the moment, limited data to make decisions with a focus on continents such as Africa and Asia, but also Europe. And really your ambition, as I understand it, is to help grow WEO into a trusted climate analytics provider. So could you say a little bit about really the challenges that you're looking to help solve with your work at WEO? Over to you, Charlotte.
Yeah, hello everyone, and thank you, Graham, for this nice introduction. And yeah, indeed, so as you already said, what we try and do is to basically make the information that is hidden in the satellite accessible for everyone here on the Earth, and not just for the ones that can afford the more expensive data sets. So it all started 5 years ago, and my co-founder Meshi and myself, we were already working with satellite data, and we realized that there's a lot of information hidden in them that is actually not accessible for the decision makers or for the people that need to get this information. And so the main ambition we had, our main goal we had to start with, was to make this accessible. And so how we try to do this is basically to take the satellite information and get the detail out of them that is needed and convert it into actually understandable indicators that can then be used. And yeah, so that allows us to fill basically the gap of like outdated data, because the satellite is available regularly and it's unbiased. So it's not just data that can be there on a project base, but it's data that can be there on a very regular way in order to provide it, for example, for preparedness of disasters. Yeah. You're on mute, Graham, so we don't hear you anymore.
Sorry, well spotted, Charlotte. There was a truck going past outside, so I'm muted briefly. So what sort of particular disaster scenarios have you been addressing with your work?
Yeah, so we've been actually starting off a lot working on urban heat. So looking at heat risk and about the impact it can have on many different aspects. One is, for example, people themselves that are vulnerable to extreme heat, such as elderly or young, but also obviously then workers, but also it can have impact on cattle or others. And then we have broadened this. We have done a lot of environmental analysis looking at vegetation, which led us to also look at wildfire risks and analyze basically the propagation of wildfires through vegetation and the risk it then poses to communities, remote communities, isolated communities, but also to little villages and assets such as ground-based solar panel installations and others. So here it's really about how this can spread through the vegetation and what can be done to be prepared and to basically avoid this risk coming too close. And similarly, we have been also looking at flood risk. So basically looking at how in urban areas or in communities, the flood risk can be increased by, for example, increasing ceiling surfaces, the reduction of retention of rainwater, and then which properties or which neighborhoods are more prone to these risks than others, and what could then be looked at for solutions.
And just before we go on to the solution, so what you were saying earlier was that really satellites are providing a very sort of rapid and available data set. What sort of data is there without satellites currently? So just to understand the baseline from which you were working.
Yes, so usually there is information based on either it can be one-off projects that have been done with a full-scale study. It can also sometimes be in collaboration with, for example, universities, or actually something that is done directly by the government, for example. And then, of course, there's a lot of local knowledge as well, usually in communities from back in time and from basically knowing their lands and what's happening historically. And so maybe the idea here was to basically bring it all together by complementing it with satellite data. The satellite data allows us to go beyond like the borders that the community might have and look at it at a bigger picture. It allows us to fill the gaps that are done project-based because we can update it regularly. And it allows us to basically then understand the local context together with the broader context and then try to find solutions that meet the needs of the local communities, but also include the understanding of this broader context. That's really what we're trying to do here.
Great. Well, I think let's go on to the solution that you've developed. I think you've got a few images as well to give us a bit of a sense of what impacts they're having. So go ahead, Charlotte.
Yeah. So this is actually what we have been discussing, that it basically we have satellite data, it's globally available, and Wirion has been focusing on using openly available satellite data to make this accessible for everyone here on our Earth everywhere. And so what holds us a bit back to use this data, even though it's openly available for everyone, is the native resolution, which might sometimes be too coarse for communities, for cities, and for then in that sense also decision makers. And so the first step for Wirion and the main goal was to get the detail out of this coarse resolution to the detail that is needed by our clients in the end. And so the main hack is built on this to extract it at more detail by combining it with other openly available data, such as orthophotos, but also local information that might be available. And so, yeah, that's what you see here on the image. This is a city in Europe, actually. And from there, then we can understand the risks. So we have the information with the detail we need. And if you go to the next slide, we can see actually then a bit what I've been talking about already. So we analyze the vegetation to understand, for example, in wildfire risk, understand where is the location and how can it spread the wildfire to my asset that I want to protect or to my community that I want to protect. where is it, but also in what condition is it? Is it water stressed or not? And this information is in the satellites because we have the advantage of having a lot of spectral information that might not be in our orthophotos, for example. And so this allows us to then understand this by combining the different maps that you see here into a joint understanding of the risks, and then including as well what potential solutions could be there. And that's also, the whole process uses AI, but a lot of the AI is also coming into this understanding and then proposing solutions, many times in combination then with what we get from the local authorities or communities. So it can already be reports that have been done in the past, it can be evacuations plans that they're having, it can be even more local knowledge. So in the next slide, you can see when we work with communities. So every community member is able to comment and give us his own personal experiences. Of course, then we have to, this is then filtered again using AI in order to filter out the comments that are useful, but then it's fed back into our risk mapping and especially also the solutions mapping using this information. And it's really for us an important part to not just provide what we get from the satellites, but to make it accessible, understandable, but also to integrate this local expertise, to not miss out on that one, which we think is very valuable.
So do you want to explain this slide in particular, Charlotte? I think you were talking about understanding where roads might be affected by floods when you presented this at the event that I was at.
Yeah, so indeed, so this is a bit how our portal looks like. So I mean, I will not go through every detail, but indeed, so there's different details that you can see here. So when you see the trees that are located, and then you see the little community that is quite remote in Australia here. It has been done. This portal has been co-created with the Red Cross in Australia and the local community. And basically, the information we could get from the local community is indeed a lot of this detailed knowledge. So, for example, we have our flood risk assessment, but then the local community knows in detail which streets are the ones that are regularly flooded and which streets are not, for whatever the reason is. They also understand if the trees in their backyard have actually been recently pruned and therefore will not bring the fires too close to their house, and so on. And so when they comment on this feeds into our database. This allows us then to feed it into our AI models to increase the understanding behind it. And of course, we then also implement that again in our risk mapping and also in the solutions to say, okay, actually, we know this street is regularly flooded. So what could be our potential solutions looking upstream? And then on the other side, this street is never flooded. So what could be the reasons why, which then gives us again understanding of why that street isn't, for example, and what could be done in other locations.
Brilliant, brilliant. So really you're combining this local sort of data with the satellite data to create this very fine-tuned analysis of what and prediction of what could be happening on the ground, if I've understood it. And then I think you want to tell us a little bit about the impacts on people. Should we come on to that? I think you've got a great final slide on this.
Yeah. So what happens a little bit is that in certain areas or in remote communities, they don't necessarily have the tools that we have in cities where they have a whole maintenance team and so on that does the maintenance for them. And so in this community, for example, they were more or less not on their own. And as many times it happens as well, communities grow older. And also there was a big proportion of women. And so when we did the risk assessments, they wanted to be able to actually prevent this risk and do something for preparedness. And so what they decided to do is to learn themselves in order to do that maintenance. And so due to this assessment, they actually got provided a chainsaw training where they could learn to maintain the vegetation, to keep it trimmed so that it wouldn't bring the wildfires too close to their houses. And also, for example, we identified that evacuation zones were they were just taking flooding into account. So they put them into locations where we realized there's a big heat risk for them to be there. So sometimes if there's these summer floods and there's a lot of heat as well accumulated there, it's not the right location to put these evacuation zones. So this is the beauty of combining it, bringing it all together, because you can then assess it in a broader scale and understand a bit better how to plan and prepare.
Brilliant, brilliant. Well, what a fantastic image to finish on. Well, thank you very much, Charlotte. So do come back for the questions. And just to remind our audience, please put your questions in the chat as we go along, and then we'll be able to sort of pick them out and answer them after the speakers have presented. So my second speaker today, I'm delighted to have Laura Moreno, who's the co-founder and CEO of EarthPulse. She's got 20 plus years in the European space ecosystem, and she leads on strategy, very much to turn satellite-derived insights into practicable, accessible tools. So really a key theme today, making sure satellites have a practical impact. Formerly, she's worked at ESA and in the private sector, very much a specialist in Earth observation and data analytics, also with experience in geospatial modeling. And she's more generally very involved in cross-sectoral leadership. With that, Laura, could you tell us a little bit about the problems you're trying to solve at EarthPulse?
Sure. First of all, hello everyone, and thank you very much, Graham and Eurisy, for inviting us. We're glad being here. So the mission and the vision that Charlotte was talking about is like very common and very similar to ours. We try to really turn this data into usable data for non-experts. But if I go directly into the risk challenge, what we're trying to solve here, it's going from reactive to proactive. Okay, so what happens here? I think that we are, as a society, not really aware on how systematically this climate change is going to hit us every single time. And it's like we thought that every time it's going to be the last one, it's the worst one, and it's going to keep repeating. So authorities lack of the knowledge to extract the value of this data. And so that's also why we try to get this data for non-experts, this information for non-experts. And also there is a lot of fragmentation. The cost of not knowing, of really not knowing what it's going to happen and how can we adapt to it, it's very high, and it's still not really measured. Okay, so that's the main challenge. So what we are trying to do, as said, it's moving from this reactive to proactive in different scales, as I'll say later on.
Thanks, Lorena. Sorry, just struggling to get the mute button off. So fantastic. So moving from the reactive to the proactive, I think that was a very nice point to finish on. So could you tell us a little bit about the sort of problems that you're addressing then? You know, the specific examples of DRM that you're working on at EarthPulse.
Yeah, we're working really in different risk factors like fire, or hazards. Like fire or flooding or landslides, maybe also droughts. Okay, we selected those because we're the ones hitting more heavily and have more consequences to economics and society. Okay, so I like to make something like clear. We take risk as a combination of 3 different factors. One is the hazard probability. One is the exposure. So what's in the area, okay, that it's going to be hit. And also the vulnerability. So how quick you are going to be able to stand up again, okay? And so the combination of those 3 factors is what we call risk in this sense. And also we have to think in 2 different scales, or we are working in 2 different scales. One is like the long-term scale, where the projections of climate are very, very important. And that's for adaptation, of course, but it's like kind of for planning, no? Like, okay, you better protect this area because it's like more prone to be flooded than this other one, or you better not build anything there because it's a exposed area. Okay, and there's the other scale, time scale, where there the meteo, it's like turns to be more important, the meteo forecast. You have like a baseline of risk, which can be also dynamic, but it's like week by week, for example. And instead of applying like climate projections for years, what you do is you force the system with meteo projections, for example, so you can get like early warning systems. And there you get operational intelligence somehow based in this data from space. Space is giving you data for the base risk, but it's giving you also the data for the media, it's giving you the demographics, it's giving you many things. So the whole combination of different indicators is what it turns in a projection or a simulation, okay, to plan better, or it turns in an alert to really operate in time.
Brilliant. That's very clear. The sort of long-term planning and then the sort of short-term operational management. And can you tell us a little bit about the type of, I think you're quite focused on infrastructure, risk management. Can you tell us about the sort of infrastructure that you're looking to protect from your work?
Sure. In one hand, we have all the cities and society, okay? And the other one, we have a lot on utilities, okay? So we work for cities or regions, and we work for utilities as well, okay? And of course, insurance, that's insure the utility. But which kind of utility? It's roads, it's rails, it's also power lines, are normally linear utilities. Because it has a lot of sense that satellite data, which is global, it really operates good at big scale, you know? So in the end, if we are like in a very small and specific area, it's maybe not worthy to use that much of satellite data because it's maybe not cost effective. But when you are a global company having assets all over the world, then it's when space data is brilliant and it's very cost
Amazing.
effective.
And would you like to, I think you've got a few images to show how
Yeah,
you've
sure.
particularly sort of managed a risk in one country. So would you like to take us through some of those?
Sure. Yeah, that's, for example, I was telling you about these two different scales. So these ones and the first slides that we can show are about the long-term scale in order to plan. That was, for example, in República Dominicana, in Dominican Republic, a project with ESA and World Bank, where ESA is like the one delivering the procurement, and the World Bank and other international financial institutions are the final users. Here, what we had to do was assessing with the different climate projections the risk of flooding and the risk of landslide. Okay, so if you go through the slides, you will see the different perils. No, as I said, that was flooding. This is hazard, and here we have to first build a baseline. We had to do a gap. I mean, one of the things that we always have to do at first, it's build the baseline. Normally, the data, it's scattered into different authorities. So we have to gather all this data, put it together, build the baseline, and do that gap analysis and say, okay, let's see if with past satellite data, we can cover the gap that we have with the data that it's in between the different authorities. Once we do that, we have like the baseline for flooding and the baseline for landslide hazard, okay? But this is only the hazard. Then you have to work on the exposure and the vulnerability. Then if you go further with the slides, you can see the diverse projections depending on the IPCC scenario. Which are the IPCC scenarios? The IPCC scenarios are, IPCC is an institution that does different projections for the climate, saying, okay, in the best case, we're going to increase 1 degree, and in the worst case, we're increasing 5 degrees. So what is going to happen in each of those scenarios? And so we take the baseline and we say, okay, let's see what happens in the best case scenario, in the middle one, in the worst one, so they can really see how it's going to evolve in terms of landslide and hazard. And if you combine these two together, it turns that in República Dominicana, for example, there were like not many places where population ideally should kind of be. Okay. And well, this is like, as I said, if you go farther through the different slides, you can see other IPCC scenarios. This is, you can see here that the risk is changing depending on what would it happen. We're working on what if scenarios all the time. Okay. So the planner, it's able to say, and if it happens, how it's going to be hit the population. And this is simply how we collect the information, we prepare the information, we did the flooding hazards, we have a lot of data. We have to, I mean, it's very important what Charlotte says also. I'm almost always forgetting to talk about it, but what it has changed the last years is like the computational power that the AI is giving us enables that this data, it's really also brilliant. It's AI, it's a key enabler for Earth observation data because the computational power, it's unmatched, and we can do unsupervised processing of many things, and we're able to process a lot of data in a very short time. And well, we process a lot of years of data in this case. And if you go farther, I think you will be able to see on the slides, if you go on a slide farther, I don't know if there is any other slide here. Yeah, this one, exactly. Thank you. So this one, it's the other case in the terms of not in that's also landslide, but this is in the other time scale. This is for operational intelligence, like what is happening today and what's going to happen tomorrow. In this case, we're mixing, also thanks to our partner Detectia, we are mixing like the subsidence data with INSAR processing. We are mixing vegetation trends, humidity, because the humidity fixes the terrain, the vegetation fixes the terrain. Okay, humidity is very important to see. Also, it's a factor in the landslides. We mix a lot of other data, like the past events and the geological information of the soil, etc. And we built a model. This model is going to tell us the risk, like today, and the forecast, and it's forced by triggering factors like metadata, which are found when you build a model. You see which factors are weighting the most. Okay. In this case, was the accumulated rain at 20 days the most important factor. And so we were able to say, and we were able, again, there's a chat to ask like what is happening today or tomorrow, and where do we have the most important place to go, where's the higher risk. Okay. So it tells operators what to do today and how to prepare for tomorrow. So that's a very different time scale from the one that we have seen before. And I think that tackling risks should take a combination of both.
Great. So in a nutshell, you've used quite a long time series of information so that you can create a model using AI of how effectively things like rainfall or drought, or indeed average temperature, will affect the risk of landslide. And then
Exactly.
using that model, you both create this risk map, but also you're able to predict in real time where perhaps an accumulated period of rain may lead to risk in a particular area. Has this now been put into practice? Are decisions being made on the back of your analysis?
It's operational. And here what we are saying also is that we have to, as a startup, we have to build a lot on the SLA and the legal things to mind here, because in the end, this is an information system. The decision, it's like taken by the operator, but it's operational. And it's, I mean, when you go to operational, there are many other things to take into account that at the beginning, as a, let's say, scientist or coming from this sector, you really never think about, but it's turning to be very interesting and real, you know.
And in the case of the Dominican Republic, there, who is the user for you? Who are you
The
providing
user
this
in
to?
it's World Bank in the
Right.
Republic, okay, in the Dominican Republic, and it's an utility. In this other case, in Chile, that was Chile, the one that I show. It's an utility, so both public and private. And it happens also that in many countries, the utility is also public, so it's all kind of together.
Amazing. Well, thank you so much, Laura. That was really, really fascinating and really encouraging, actually, that we're now in a position to manage far better these really serious risks, both to people, to the environment, and obviously to sort of key economic infrastructure. So let's go on to the Q&A. So
Sure.
We look to our back office team who are hard at work going through the questions. Here we are. We've got one from Daniela. So thank you for your question, Daniela. So the question is, from your experience in Central Europe, including countries like the Czech Republic, do public authorities make sufficient use of satellite data across all phases, or do they tend to use it mainly after the crisis has occurred? And what would strengthen trust in satellite-based information? Well, I guess that's a question for both of our speakers. So who'd like to go first? I see Charlotte nodding. So Charlotte, why don't you go first?
Yeah, look, no, I think it's a very good question. And I do think in Europe, there's a huge focus on near real-time monitoring of actual hazards when they occur, and then after hazards to monitor the recovery and monitor the damage that has happened. And there's still much less focus and budget on the preparedness and planning before hazards. I do think it's something in general where we have to step up, and it's something that became very clear in Spain this year as well. I guess, Laura, you might know as well, but like we work with communities in Spain, and there are these wildfire plans they have to do for their communities, but a lot of them are just done as a have to do and are not really updated with actual data. And I think that's what now we are realizing with these hazards happening more often, more unpredictable, spreading quicker. We need to update those plans more regularly, and we need to account for a wider range of information as well, going beyond, as I said, beyond our communal borders, but also understanding a little bit more how do things spread, and it just doesn't just happen in this specific location. So I do think it will change. I think the trust in satellite data is increasing as we go, also by having more and more of us producing this type of product. But it's something we have to build on, I think. Laura, maybe you want to step in as well.
Yeah, you know what happened? That many times the mandate is different. I mean, it's also a political thing. It's different departments, it's different authorities. I mean, the preparedness and the reaction are many times in different authorities or different entities. So that should be kind of together. What you said about Valencia, a year before it happened, we were indeed talking with the emergency unit, and we were speaking about preparedness, and it's like out of their mandate. It's completely out. Mm-hmm. That's for another unit, which is really not so relevant when something happens. So are like very disconnected. And I think that the awareness in Europe, it's there. And this is a thing that it's going to change. But we have, as I said, everything is super fragmented. And this is one of the main challenges that I was saying at the beginning, the fragmentation and the fact of changing from reactive to proactive. But I think it's changing slowly.
Yeah, I mean, I guess, we often hear about crises in Europe when things get completely out of control and something very bad happens. And I wonder whether if we can try and promote success stories of where people have managed and mitigated, a wildfire, a landslide, or a flood because they did the sort of thing that we've been talking about today, then that will create, I think, as you were saying, Charlotte, a huge expectation on local authorities that they do take action, they do manage these risk analyses proactively. Because if they don't, they're going to be asked why they didn't when the tools exist.
But the measuring this, I mean, as you said, after something that happens is what it's being done. Ideally, you have to measure it kind of before, but the cost of something that doesn't happen, it's very difficult to measure. I mean, the cost of avoiding, how do you measure the saving of avoiding if you don't have the example like of a crisis hitting? You know what I mean? The cost of not knowing and measuring it or putting into value before it happens, it's being very difficult.
But maybe also, as you said,
go on, Charlotte.
Sorry, just one last comment, and then maybe also, as you said, Graham, I think one thing is as well that actually it's a circle, right? So the recovery again is also the planning, and I think that's also how we can close this circle and also stop looking at it in two different spaces, because actually we do need to look at preparedness and planning when we do recovery. Yeah, so that just to close that.
No, very good point. As you say, DRM is very much a circle and a cycle, and we should absolutely take the learning from events and then factor them back in, because I'm afraid the truth is they will happen again. So we've got some more questions. Perhaps the team could select one. So a question from Torsten to Laura: who are your clients today, and are your engagements with your clients one-off or long-term based? So yeah, are you getting sort of repeat business and operational service demands? Over to you, Laura.
So hi, Torsten. Thanks for the question. Our clients are mainly utilities, insurance, and supply chain markets. That's in the private. And then in the public are public administrations, normally like cities, or like the institutionals like the World Bank or the Asian Development Bank. Okay, so those are the clients. Then they normally try for something like 6 months or a year, depending on how complex. And once they understand and they bring it into their workflow, their normal workflow, they turn into operational, and the engagement are yearly normally.
Thank you, Laura. Can we have the next question from the team? I can see there are questions in the comments. Fantastic. So one from Alban, good morning. And another question to Laura. Okay, you're getting solicited here, Laura. Does a country need a strong technical capability to benefit from your work, or can this work even with limited local resource? And how quickly could we perhaps do what you've done in Dominican Republic in another Caribbean country?
Alban, that's a very, very good question, because here the whole point is, it's like just the two things that you have asked. First, there is no technical expertise that it's needed to extract this information, this knowledge from the data. The technical expertise is in our side. We deliver the knowledge and the information and the tools for the non-expert to be able to use this data. That's why we say we make usable this data, because it's very useful, but usable, okay? And so the second thing that we really are focusing it's the replicability. Once you do, or you have your solution, you as a World Bank, or for example, as an institution, or as a utility, as a client, you shall be able to take and replicate the solution all over. Okay, so we have these global models that we train locally, but once we are, if you have the data, you can retrain the model, but if you don't have it, you will get like maybe less accurate, but still you get the information, but you can like operate it globally. So that's the thing: replication, no knowledge, and also, let's say, integration, as well as a third thing that we really think are like the game changers to be adopted.
Okay, thanks, Laura. Well, that question was put to you, but maybe Charlotte, you've got a view on that as well. So I'll ask Charlotte to have you.
Yeah, look, I think it's similar. So in a way, our solution is scalable for everywhere, and we can implement it everywhere. The local part is also something, obviously, that is then subject to the local inputs that we get, and what is the community like? What access do they have? Like, what tools are they using? So there we tailor it. But the models themselves are the models that do the risk analysis and also the solutions, and all of those. They are trained and they are scalable globally. But the setup per community or per client, in a way, because when we work with asset managers, it's slightly different what we do than when we work with remote communities, or also when we work with cities, it's different. So this local setup is then done for each one.
Yeah, that's very clear. I mean, ultimately, this has to be used by somebody, and it has to be tailored to their capabilities and focus. So very good thoughts. I can see there's one more question from James. I'll just read it out. James is leading the Geospatial Research Forum, and he's asking, what's the potential to work leverage the approaches here? I think in Uganda. So, are you looking at, maybe we can broaden this question, are you looking at Africa as an area of application of the sort of tools you're developing? Who'd like to go first? Laura?
Yeah, it's fine. Absolutely, yes, James. We are also using a lot of geospatial data. Many of the data that we use are like our local data or open data from maps or many things. We do have integrations with QGIS and ArcGIS and many other geo softwares, for example. And also, as we provide solutions for many verticals, when I show the landslide, I also mentioned that the Tectia team, we federate solution from third part and we put it like together in the model, okay? So we collaborate very much. We have integrations like in the input and in the output. So for sure, there is a lot of cooperation and things that maybe used to accelerate the impact of your work into the real world. Sure.
Thank you, Laura. And any thoughts, Charlotte, on the question around biodiversity risks? So moving away from sort of things that people just naturally think about, there are other disasters that are happening perhaps slightly on a, not on a day-to-day, but on a month-to-month and year-to-year basis.
Yeah, indeed. Look, so we are working on that in a way. Of course, biodiversity is a very broad term and there's a lot that comes into that. But what we look at it in that case, and it can be done in Uganda as well as it is done in other places, is to look at, for example, the vegetation and how this vegetation is connected to create corridors, border, or if we talk about fauna, for example, as well as looking at vegetation types, looking at are we having full-grown forests, are we having forest farms, are we having like this type of analysis can be done using the space data for Uganda, for example, and we do these analyses as well, which we put more into environmental mapping, but it is part of risk and disaster management as well.
Super. Well, look, I think we've covered all the questions and we're about at time now, so I'd just like to thank our speakers again. Really fantastic presentations. Really interesting to see where you're going with your very innovative companies and the amazing impacts you're starting to have. Both, I think, really what's coming across clearly is the power of satellite data that's out there, huge amount of it, becoming more and more available in terms of revisit rate. We didn't really talk about that, but also resolution, and then AI as a tool to pull that in. And another thing that we hear a lot about DRM is that actually the power of satellite data increases over the longer the time series that you have it for. Sure. And now we're starting to see that we've got this time series for sort of up to 20 years globally, but also now the European Copernicus system is giving us time series of about 10 years. So the power of satellite data will only grow, I think, and the potential for what you're doing will only get greater, and it's clearly critical that it does. So thank you to the two of you. Thank you to our backroom team who've done a fantastic job in the hidden away. That's Betty and Frank. And also thank you to all of you that joined us today. It's been a really, really engaging webinar with lots of great questions. And just to say, we'll be taking a pause now for in the new year on Down to Earth, but we hope to be back with you soon with another area of application of satellite data. So thank you once again and goodbye for now.